Hi, everyone. I'm Jacob Haqq-Misra. Thanks for coming to my presentation. So today we're going to talk about the question, what is the value of exoplanet science? And now when I say value, I mean value in a philosophical sense. And so we start by distinguishing between two types of value. There's instrumental value, which means something that's a means to an end, and intrinsic value, something that's worthwhile in and of itself. And so we might think of humans as intrinsically valuable. We're all valuable just by being human, but maybe the work that you do has different instrumental value. Now, in this presentation, we're not going to talk about human ethics or even animal ethics, but really about planetary ethics. So I'm really going to be thinking about what's the difference between the instrumental or intrinsic value of a planet. So we're going to break this down a little bit more. There's different kinds of instrumental value. So there's demand value. We're going to say, this comes from philosopher Brian Norton. It satisfies a felt preference, something that we want or prefer right now. And so this could be what we're going to call use value. This is demand value that's realized today, instrumental value realized today. Or this could be option value realized in the future. So on Earth today, we realize a lot of value just from the planet itself. But you can think about future settlement of Mars, realizing an awful lot of value. Now, this doesn't exist right now, but we can imagine it, and maybe this could exist, in which case, this is why we maybe say Mars has some option value. Now, there's other types of value that are non-demand value. So this is something other than satisfying a felt preference, which is what demand values were. So what else is there? Well, there's existence value, we're going to call it. This is an intrinsic value. And since we're talking specifically about planets, we call it existence value. And it's the idea that nature's projects are valuable. And this might motivate scientific study of different objects in nature and planets in particular as examples of the projects of nature. And then a final type of non-demand value is an instrumental type of value that we're going to call transformative value. This is something that examines or alters a felt preference rather than satisfying it. And so transformative experience provides a way to catalyze permanent epistemic change by examining the boundaries between the self and the environment. So the value provided by transformative experience is not necessarily giving us something that we want right now or something we want in the future. It's not studying a thing for its own sake. It's actually an experience or some sort of value that catalyzes permanent epistemic change in ourselves or in our society. And this is one of the great examples of a transformative result from the space program, in which this is a photograph taken by a human photographer in orbit around the moon. And this is one of the most widely distributed images. One could argue that this gave birth to Earth system science, as well as environmentalism and many other ways of seeing ourselves as Earthlings and as a human species. So we can think about these four different types of value in this graphical scheme that I've developed. And so here we have use value on the upper left, option value on the upper right, existence value in the lower left, and transformative value in the lower right. Now, I don't have numbers on this. You could think about ascribing numbers if you want to, or we can just think about this in a qualitative sense, about just thinking about the different, more or less types of value along these different axes when comparing different planets. So I'm not going to put numbers on here, but that's certainly something you could think about doing. So just to start, I've got Earth as a square here, just as a reference point. So we're just going to say Earth has some use value because we're using it today. It has option value because we can think about other ways we may use Earth in the future. There's existence value because we value Earth for its own sake, and we may study processes on Earth as examples of nature's projects. And Earth routinely provides us with transformative experiences. There's transformative value to Earth. That could be hiking to see the Grand Canyon, or just waking up and seeing the sunrise, and it inspires you in a way that it's never inspired you before. Many, many examples that I won't get into here. So let's think about other planets. Well, so here's Mars. Mars, we're not using right now. Not really in the sense that we're using Earth, but there's the option to use Mars. I showed the image earlier. We can think of many, many ways that potentially we could use Mars. And so there's great option value in Mars. Now, Mars holds existence value as a planet that's, an example of something nature does, and we studied Mars for its scientific value. And then there's the transformative potential for Mars. And there's many examples you can think of, whether it's from things at AbSciCon or other meetings or science fiction. But you can imagine primarily sending humans to Mars has tremendous transformative potential in the individual experiences and the collective experiences that will arise from that, in a similar way that the first astronauts to orbit Earth and the first ones to reach the moon has led to transformative experiences. And even some of the more recent commercial space flights that are giving people that experience of space flight and the overview effect can come into play here as a transformative experience. So we can contrast Mars with asteroids. Asteroids have little use value today, but high option value, primarily in asteroid mining and harvesting resources. Asteroids have existence value, but we may say they have lower existence value in the sense that there are many common asteroids that are similar to each other. And so studying Mars as an example of nature's projects is a unique example, but maybe certain asteroids are more unique than others. One could argue. And then, what is the transformative value of asteroids? Perhaps there are some, but maybe there are more transformative opportunities to Mars exploration than there are to asteroids. That's something we can discuss for sure. But we can then think about exoplanets. Now, exoplanets are pretty different because we're not going to be able to use them anytime soon at all. And so, one can speculate about science fiction that send, humans to exoplanets someday, but in anything resembling, even short or medium range, planning, you have to be thinking very long term to be thinking about, this interplanetary or interstellar settlement is very far off. Interplanetary settlement, we can think about Mars, but interstellar settlement is very far off into the future. And so for now, what motivates exoplanet science is not the idea that humans may go there someday. It's the idea that exoplanets are great examples of nature's projects. We have a huge diversity of exoplanets that do not exist in the solar system. So we learn a lot about planets, about things that planetary systems can do by studying them. But then what other kinds of value do exoplanets provide? It's transformative value. It's mainly this question of, are we alone? And can we find evidence of life? Are there biosignatures or technosignatures that we might find in exoplanetary systems? And if so, what's the implications of that? Now, that's not use or option value. That is something that is going to provide epistemic transformation to ourselves and our societies. Now, we may not know exactly what that's like. There was a wonderful workshop on communicating the discoveries of extraterrestrial life that NASA hosted recently. And there were great discussions about what those scenarios might mean in which you discover a biosignature or even a technosignature, and what would the impact be? We don't know. But we can speculate that certainly it would be transformative. And we can at least point to examples like the images of Earth from the Apollo mission as some examples. And there's many others for sure that we can think about, what were the transformative outcomes of this? But now it's important to keep in mind these differences drive differences in the political landscape. They can contribute to funding decisions. Mars exploration continues to maintain scientific and political inertia due to the high net value in Mars across numerous stakeholders. There's option value and existence value and transformative value for Mars. You're engaging many communities. Exoplanet science is great. I love it. It cannot provide any value for human exploration. It has to justify itself through the advancement of basic science and then high-risk objectives like the search for extraterrestrial life. Now, I think we should do this, but framing it in this value graphical framework, I think, can help to kind of illuminate the different features that each of these scientific endeavors has. And certainly we have to acknowledge the reality that something like Mars, it's closer. There's a lot more that one can do with it. And that's going to contribute to just the difference in interest across different stakeholders for Mars, as well as asteroids versus exoplanets. And so, of course, I think it's important too, then, for missions like the Habitable Worlds Observatory and others to continue emphasizing that one of the purposes is this high-risk objective to search for extraterrestrial life. It might be a high-risk objective, but it would be a transformative result if we were to obtain it, and that is a lot of the value that exoplanet science provides. And so if you enjoyed this, if you want to learn more, I talk about this in my book, Sovereign Mars. All the figures are from the book, and specifically Chapter 7 on transformative value. We'll have more about this, as well as some specific examples about the kind of empirical studies on transformative value that we might learn something from. So thank you very much.